Welcome back to You Can Do It. Today we're doing the practice paper for the new specification and the one without a calculator. This is going to be new. Let's jump right in. Question 1 tells us to write down the order of rotational symmetry of a diagram. So remember, there are two types of symmetry. There's reflection symmetry or line symmetry, that when you draw a line and the two sides are equal. For example, if you would draw a line through here like this, you will have line symmetry. I think, no, we won't, because that won't match that. Okay, in fact, I don't think this has got any lines of symmetry. But what they're talking about is rotational symmetry, and the best to see this is with tracing paper in the exam. They should give you some tracing paper if you ask for it, or provide you with it from the start. So if I put this over there and then we rotate it, okay, now remember, let's make it circle there. We need to rotate it until those little dots are back on top of each other, and we need to do it around the center of the shape. Sorry for my badly lit. So if you rotate it, see, goes around, goes around, goes around. There, it fits once, and we go, and we go, and when we're back on top, that is 2. So rotational symmetry 2, and that's what you write on the paper. 2, that's it. You get 1 mark for the 2. Going on to question 2. At noon, the temperature in Maseru. You know where Maseru is? Lesotho. Been there. Nice place. Well, it was 21 degrees, and at midday the temperature fallen. Alright, so you're at 21, and you need to go 26 down. So you're going to go away, you're going to go past 0. Let's say you're at 21, and you go down to 0 degrees. Of course, that's 21 down, so you need to go another 5. So that makes up 26 degrees. You go down, you'll end up at negative 5 degrees Celsius. Yeah. Minus 5. As you can see in the mark scheme. 1 mark for the correct answer only. Question 3. Multiplying decimals. You can do it like multiplying normal numbers, right? What we do? 3 times 7 is 21, of course. And then we just count the decimal numbers. That's the numbers that's to the right of the decimal point. There is 1 there, and there is another 1 there, and another 1. How many digits is there to the right? Okay, that means our answer needs to have 3 digits to the right of the decimal point. So we're going to keep the 2 and the 1, which is 1, 2 digits. So we need to add another 0 to give us 3, and that's in 0.021. Yeah? Count the digits, the decimal digits, 1, 2, 3, just like in the question. And then you see 0.21, 0.021, or equivalent. So I can't imagine what will be equivalent to that. I guess you can write it as a fraction. That will be equivalent to that. 21 over 1,000 would be an equivalent answer if you want to try. Okay. Division, though, is quite different from multiplying decimals, right? For division, what we want to do is we want to get that second number, the one that is being divided into the prior number. We want to get that whole number. And we can do that by multiplying this one by 10 or 100 or 1,000, whatever you need to make that a whole number, which will make this 2. As long as we do the same to the other number, exactly the same, the question, the answer will not change. So 8 divided by 0.2 gives us exactly the same answer as 80 divided by 2, which is 40. And that's the answer. Don't change the answer afterwards. That is the answer. Think about it like this, right? You've got $8 or 8 euros or 8 pounds. How many 20-cent coins will fit into it? And the answer is 40. That's what they essentially asking. And 40, again, the correct answer. A square number greater than 10. Okay, what are the square numbers? 1 times 1 is 1, so 1 squared is 1. That's not greater. 2 squared is 4. 3 squared is 9. 4 squared, 16. There we go. That would be the first one. That's the one I'll go for. But I can imagine you can do 25, 49, 64, 81, 100, 125. It goes on infinitely. Any square number greater than 10. 1,000. Whatever you want. Okay. 16 being the smallest. Reciprocal. Reciprocal means the inverse. The opposite. So you have your fraction, you flip it around, you have the reciprocal. For example, the reciprocal of a half would be, it's not equal though, 2 over 1, which of course is 2. So we can do the same with 20. We can put 20 over 1, and then as the reciprocal, if flip it around, is 1 over 20. Okay, the rule is if you multiply a number by its reciprocal, the answer is always 1. Like the first example there, a half times 2 over 1 will give us 2 over 2, which is 1. Just the same here. 2 over 1, 20 over 1 times 1 over 20 will give you 20 over 20, which is 1. That is what a definition of reciprocal is. Either way, the answer is 1 over 20. Just flip it around. Okay, and you can write a decimal answer as well if you feel like it. Area of a trapezium. This is probably one of the formulas that is most forgotten. Okay, in the new specification they give you this list of formulas and area of a trapezium is not there. Make sure you study this one. Alright, make sure you study this one. The area of a trapezium formula is half, like for the triangle, but then A plus B times the height. Okay, A and B being the two parallel sides in any order. Okay, and the height is the perpendicular height, which means it needs to make that 90-degree angle. Okay, so this is just something you need to memorize. Make yourself some memory cards. Go over it over again. So this would be 11 plus 7, or 7 plus 11, that doesn't matter, multiplied by 6. Now without a calculator, 11 plus 7 of course is 18. Half of 18 is 9. 9 times 6 being 54 centimeters square. 54 squares fitting in that trapezium. There we go. Get 1 mark for using the formula correctly. See, they use it a slightly different form of me. 7 plus 11 divided by 2, which is the same as multiplying it by a half. Okay, whatever you're in the world, your formula might be slightly different, but it comes down to the same thing. Find the value of x. Always look at the information they give us carefully, right? AB equals BC. That means something. Focus your attention to that. Focus your attention to these two lines, which means they're the same, which gives us an isosceles triangle. Isosceles triangle, two sides the same length. The rule is always the base angles are equal. The ones at the end of those equal lines. In this case, it will be angle ACB, which is x, will be equal to angle BAC, so this will also be x. Okay. Long way to do this question is work out this angle, of course, which will be 130. Angles on a straight line. Do subtract it from 180 divided by 2, which gives you 25. But there is another rule in triangles. I don't know if you remember this one. It states that the opposite exterior angle, this one, is equal to the two opposite interior angles. So it means that these two angles here, if you add them together, you get that exterior angle. In this case, it will be these two x's. If we add them together, those two x's, it will be equal to 50. It's a bit quicker, because it means all you need to do is do 50 divided by 2, x is 25. Okay, just make sure your 5 looks better than mine. 25 degrees. But like I said, you can do 130, 180 minus 130 is 50, 50 divided by 2, you get the same answer. Okay, let's check the mark scheme on this one. 25, there it is. You do get a mark for 130. Okay, this is now if you don't have 50 divided by 2. So, my advice is always, write in as many angles in this thing as you could. If you make a mistake somewhere else, you'll get 1 mark out of 2, 50%, just for writing down what you know. Okay, remember that. Standard form, remember standard form always has a number from 1 to 9, number smaller than 10, decimal point, rest of the number, times 10 to the power of something. This case means we are going to move this decimal point to behind the 6. So we're going to go 1, 2, 3, 4. We now got 6.7. That's the first definition of standard form. It has to be a digit, then a decimal point, times 10 to the power. We moved it, remember, 1, 2, 3, 4 spaces. And because it's a very small number, we put the minus. Small numbers got negative indexes there. Okay, there we go. I think that's the only correct answer will be exactly that. Good old fractions question. In the old papers, you could check this with your calculator. Now we can't, of course. There is more than one way of doing this question. In this case, I think it would be better to change that first fraction into an improper fraction. So what you want to do here is, you want to say, I've got 1 3/4 of a pizza. You've got 1 3/4 of a pizza. Yeah. What does that mean? Actually, I've got 1, 2, 3, 4, 5, 6, 7. 7/4 of a pizza. 1 3/4 is the same as 7/4. Quick way, 1 times 4 is 4, plus 3 is 7. Okay, minus 11 over 12. Okay, next step would be to get the denominators the same. We're going to do that by multiplying the first fraction by 3, which will give us 12 at the bottom. That's what we wanted. We wanted that the same. Top 7 times 3 being 21. Now we can do basic subtraction. 21 minus 11, of course, is 10. The denominator stays the same. It says there, write it in the simplest form, so that's important. Now we simplify this. We can divide both by 2, which will give you 5 over 6. Okay, look at that. 5 over 6, correct answer only. Okay, you can get 1 mark for 7 over 12. 9 over 12, of course, is the other method. And then 1 mark for getting the denominators the same. Just in case you've done the other method, you can skip over this if you're happy. But the other method would have been, you left it as 1 3/4. Okay, and then again, you need to get the denominators the same. So that will give you 1, and you're going to multiply it by 3, of course, not by 2. Okay, so you multiply, same as this before, which will give you 9 over 4. But then you get into this problem is that 9, that should be 12 now, of course. 9 minus 11 gives you a negative 2. So you're going to have to take that 9 away, and that 1, you can write that as 12 over 12. So you could say 9 minus 11 is a negative 2. You're going to have to take that 2 from the 12 at the top there, which gives you 10 over 12, which you then simplify to the same thing. So the other way, whichever works best. The best method is the method that works for you, the one you understand, okay? Question 9, and this is a transformation question. Remember, there are 4 types of transformations. We get a rotation. Okay, and that goes is when something rotates. Okay, so we're going from triangle T, that's very important. Now triangle T onto U. Now this kind of looks like a rotation. Okay, a rotation would look like this. If we were to trace the shape and we were to rotate it around somewhere around the middle. Ooh, that's a slip. Somewhere around the middle, rotate it around. Bam, see, that's the rotation. Problem here though is, it's a bit too big, isn't it? Yeah, If it was the same size, we would have had a 180 degree rotation. So that's not it. What else do we get? We get a reflection. And reflection is a mirror image, of course. And that you can describe by actually flipping it over. Okay, so if we had like a mirror line here and we'd flip it over, actually, it would look like this. It would lie flat because the distances would be the same. Again, it's too big and it's not rightly orientated. Then, of course, we get a translation. Okay, and that's when it moves across the page and moves down. So okay, it doesn't have the right orientation or size for a rotation, for a translation. Sorry, so it's none of these, because all of these, the size stays the same. It never changes. It might turn, it might flip over, it might move around, but the size stays the same. So whenever the size changes, there's only one transformation it can be, and that's called an enlargement. Okay. But it's actually getting smaller. Okay, but we still call it enlargement, and we'll see how we fix that problem in a moment. Okay, so an enlargement means it gets bigger or smaller. Okay, now normal enlargement. So if we look at this animation, which shows us enlargement, the moment the scale factor is 1, so the enlargement is exactly the same size as the shape. And there's a center of enlargement. Okay, let's see what happens. The moment I change the scale factor, it gets bigger. Now the new shape is twice as big, the red one, as the original shape, the black one. And the distance, let me move the center. The distance from the center is twice. Okay, we'll put it down here. So the distance from here to there is now doubled. If I move the scale factor of 3, now the new shape is 3 times as big and it's 3 times further from the center of enlargement. But note this, right? The shape is the same orientation. It's not upside down or rotate or anything. Okay, so how do we get an enlargement that it's the different orientation? By the way, we can also get an enlargement that is smaller. Let's do that first. You see now, let's just that. This is an enlargement of a half. The new shape, the enlarged shape, is smaller because the scale factor is a half. So it's half the shape. It's also half the distance between the center and the original shape. Okay. But what happens if we make it even smaller? Well, we get to 0, there is no shape, the scale factor, no shape. But the moment we go beyond 0 to negative, look what happens. The shape flips over. Okay, there we go, flipped over. Scale factor is a 1, or minus a 1 rather. So it's the same size, same distance, but because it's minus 1, it's on the opposite side of the center of enlargement. If we go to a scale factor of 2, it's now twice as big, twice the distance from the center, and it also flipped over. Okay, and we can go to 3 times. We've got 3 times as big, 3 times the distance. Okay, so look carefully at the difference there. Negative is on the opposite side of the center, positive is on the same side. Positive scale factor means the orientation stays the same. Fractional scale factor means it gets smaller. Negative means it's on the other side. Negative fractional means it's smaller. Minus 1 means it's the same. Now that's beautiful, isn't it? Oh, this is fun. Okay. So now that we have established that there's an enlargement, we write that down. Describe fully this transformation. So we didn't name it first. We say this is an enlargement because it changed size. Okay, and that's your first mark. 1 mark for writing enlargement. We got 2 more marks. This is 3 marks in total we need to dig out. So what are we going to do next, right? We can check the size. Remember, we're going from T onto U. That's very important. Because we got it from U to T, look at the base here, which now is up there. 1 squared became 2. The height 2 squares became 4. Okay, so that would be a scale factor of 2. It's twice as big, but we're going the other way. We're going from t to u. So 2 becomes 1, 4 becomes 2. That means the scale factor is a half. Okay, or 0.5, because the new shape is half the size. Now we got 2 out of the 3 marks. The last one is that dot we had, the center of enlargement, where it goes through. And to find that, we need to do a little trick. We connect similar the corresponding angle. So there's a right angle there, right angle there. So we want to connect them with a line. Okay. Alright. Then there's this acute angle. That's the smallest angle in this shape. Yeah. Here is the one going from the right angle up. So he's going down. Connect that. And then the last corner, we connect that one. If you do this right, you'll see all the lines pass through. Same point there. And that clearly tells that will be the center of enlargement. If you just write center, I'm sure that will be fine. Okay, and that's a coordinate point. Along the corridor here, this is of course 3. So you write 3. And then up the stairs to 4. 3, 4. And bang. Got your third mark. Questions 10. Simplifying this. The coefficients, the numbers in front of the big numbers, we can just do that. 8 divided by 4, that will give us 2. Yeah. Now the rule with indices is if we're dividing, then we subtract. If you're multiplying, you add them. Dividing, you subtract it. So you'll do here is 8 minus 4. Final answer will be 2t 8 to the power of 4. Okay. 1 mark for the 2 and 1 mark for the 4. So you get a mark for just doing 8 divided by 4 is 2. Isn't that nice? Okay. What we need to remember, if anything where it crosses the y-axis, now remember, if you think about the axis, you've got a line crossing it. Okay. This is positive, so the line will be positive. Okay, to be a line, yeah. That's where it crosses the y-axis. And what do we know about that point there? Yeah. Well, the coordinates will be 0 something. Where it crosses the y-axis, the x-coordinate is always 0. So that's what we need to do. We need to make the x 0. Oh, we can already put the 0 there. So we put the 0 into the equation over there. That means y equals 3 times 0 minus 2. Y equals minus 2. Easy as that. Okay. 0 minus 2, 1 mark, nothing else. Going on to question 12. And these are column vectors. And first question is not difficult at all. It's very straightforward to do. But I want to show you actually what's going on. So I'm going to jump to my whiteboard here. And I got the vector 4, 6. Now remember the thing with vectors is you got 2 numbers. The one at the top always tells you how much to go right or left. Of course, to the right is positive, to the left is negative. The number at the bottom tells you how much to go up or down. Of course, up is positive and negative is down. Right, so I changed my grid there because I realized I'm going to run out of space. But let's just continue with it. So we got the vector P. You start at some point. Let's say you start over here. And then, of course, we're going to go then 4 squares to the right because it's 4 at the top. And then we got a 6. So we got 6 squares up. 1, 2, 3, 4, 5, 6. And we end over there. That's the vector P. In that direction, vectors always got direction. Now, if we make it 2p, that means you just do this twice. Okay, we do it again. It means everything just doubles. The 4 becomes an 8, 6 becomes a 12. So here we go, and then another 1, 2, 3, 4, and then up 1, 2, 3, 4, 5, 6. Bam. Okay, there we go. This will be the vector 2p. Then I add to that the vector q. So we start with a minus 2. Minus 2 means now we're going to go to the left 2 squares and then 7 up. 1, 2, 3, 4, 5, 6, 7. Okay, so we've added that bit of a wonky line, the vector q. And the question then, of course, is what have we got here if we go all the way? What is that vector if we would go straight? Okay, so we just counted 1, 2, 3, 4, 5, 6 to the side. So if I do 2p plus q, I will have to go 6 to the side, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 squares up. There's the answer. Of course, you're not going to draw all of this on a grid. There's a much quicker way to do this. Okay, quickest way, you sit in the exam, you say, right, 2p means I have twice the vector 4, 6, and then I have to add the vector minus 2, 7. Okay, twice the vector p, well, 2 times 4 is 8, and 2 times 6 is 12. Add to that minus 2 and 7. So you know you just did 8 plus minus 2 is 6. 12 plus 7 is 19. You got the answer straight away. At least you understand why that is the answer. Okay, 1 mark for each. Okay. Question 2, I got us a clean grid again. And let's draw again that vector 4, 6. So which means if you start over here, you go 1, 2, 3, 4 to the side, and 1, 2, 3, 4, 5, 6 up in that direction. That's the vector p. Now when I put the p between two lines, that means the absolute value. It means there is only positive possible answers here, and I actually just want to know the length. How long is that line? Okay, so as you can see here, we can make a triangle out of it. And then what do we have? Got a right angle triangle. And who's that bloke that figured things out about this? Pythagoras. We got a base of 4 and a height of 6, because there's 4 squares to the right, 6 squares up. So all we need to do here is the good old Pythagoras, remember? If I were to make this a, b, and c, it's a squared equals b squared plus c squared. Always the hypotenuse equals the other two sides squared. And if we ever want to speed things up, we throw that square across, and it becomes square root. Okay, so what would it look like on the paper? Well, no sweat. We know the vector p is 4 over 6. So if we want to find the length of the line, the absolute value, we just do square root 4 square plus 6 square. 4 square, of course, 4 times 4 is 16. 6 square is 6 times 6 is 36. 16 plus 36 is 52. Okay. Now here we come to Surds. Surds. Put it in the simplest Surd form. Okay. We need to think, what square numbers is there in 52? Okay. Think about the factors of 52. You got 2 times 26, of course. 3 go into that. No, 4. You can do 4 times 13. See how nicely that simply double the 2, half the 26. You get 4 times 13. 6 go into 52. No, okay. I think that's about it. So we can write 52 as 4 times 13. Of course, we know the square root of 4 is 2. And that's the simplest form in Surd form, because 13, of course, is a prime number, so we can't divide anything into that. Alright, surds might be something that's a bit new. You might have to practice. Alright, so correct answer only, exactly 2 square root 13. Get 1 mark for just 4 square and 6 square. You don't even need the square root there. Okay, so basically it's so you get 1 mark for this without the square root and 1 mark for the final correct answer. So practice your surds. Question B, we are still with column vector. So they tell us A is the point 4, 1. Let's go over here. Okay. A is the point 4, 1. That is A. Then they tell us the vector AB going from A to B is minus 3 over 1. Minus 3 over 1. Remember, vectors, the top number tells you left or right. Right is positive, left is negative. The bottom numbers tell you up or down. Up is positive, down is negative. So for this one, then we need to move 3 squares to the left. 1, 2, 3, and 1 square up. And what do we got? That will be then B. So that will be the vector in that direction. A, B. And the point here, of course, is 1, 2. That's what they're asking you to imagine in your head. So what would you do in the exam? You would say like, well, this is the X, that is the Y, and then vectors, the left and the right corresponds to the X-axis. So this is moving parallel with the X-axis, and this moving parallel with the Y-axis. So the point A, you're going to do, for the X value, you'll do 4 minus 3 is 1. And for the Y value, you'll do 1 plus 1 is 2. You squeeze them together. And you get 1, 2. There it is. Okay, 1 mark, you have to both correct. And then we get to my favorite. Important thing with circle theorems is just go through the information carefully, and of course know your theorems. So we're going to start here, and we're going to look at every piece of information. It tells us A, B, C, and D lie on the circle center O. Now that tells us that for a reason. Okay, because if you look here, A, B, C, and D, what does that form? Oh, that doesn't work, does it? Okay. What does that form? It forms a cyclic quadrilateral, a four-sided shape with all its corners on the circumference. So then we go to our circle theorems and a cyclic quadrilateral here. Zooming in this one, that's a cyclic quadrilateral. Okay, see? Cyclic quadrilateral. And I want you to look at these angles that is marked. Yeah? Let's make it a nice. If I could make the one. See that? 99.9 plus 80.1. What is that? 180. Those two angles will always add up to 180. Add those together. You see? Always 89.7 plus 90.3, 180. If I move this, they stay the same. So that's the thing about a cyclic quadrilateral. The one we have looks a bit more like this. Come on. Yeah. And in fact, we got that one angle there in the cyclic quadrilateral. Something like this, which is 131. So it means 1, 1, and 1. The other angle will be, this is too sensitive, but you get the idea. Okay, opposite angles in a cyclic quadrilateral are equal. Okay, so if we look at this, okay, then this angle here, no, not opposite angles are equal, they add up to 180, plus this angle here, together would be 180. Yeah, so I'm talking about 180 minus 131 gives us 49. So this angle here will be 49. Right? That's how you do circle theorems. You just don't even read the questions. All right? Look at the piece of information And look what you can tell from that. Of course, then this angle here plus this angle here is also 180. You never know when you might need that, but we got that now. Right. Next piece of information. TA is a tangent to the circle A. TA is a tangent to the circle A. That's going to be important. They tell you, focus your energy there. What do we know about a tangent to a circle? Okay, now in your head you need to have this because you practice it hard. Okay, let's go and look. Let me zoom out. Where is the tangent? Well, this is the closer I get to the tangent. So there's two things here we can look for. Okay, first one is, no, this is not going to change. Yeah, if I put this one on top of that one. Okay. Yeah, there we go. Exactly on top. The angle between the tangent and the radius or the diameter. Yeah, always 90. Okay, look also what happened now. It's 90 here. You see the opposite angle there? That's 90. Look what happens if I change this. The angle changes, but it stays the same. See, 61.4 on the right, 61.4 over there. 55.8 over here, 55.0 over there. So remember what that tells us is the opposite exterior angle of a triangle with a tangent is equal, something like that. I can't remember the rule. What's it say? No, it's not here. Anyway, so when you see a tangent, look for two things. Look for the radius and the tangent. That would be 90 degrees. And looking for the opposite interior angle. So in this case, there is the radius going from O, the center. So we know that this will be a 90 degree angle. Okay, and then we need to look carefully. If we look like, here's the tangent, here is a triangle. Okay, there's an angle over here, will be equal to the angle over there. That will be 20. Is there any other triangles? No, I can't see it. Okay. You see that? Let me show you. Let me show you here. So that one we have is more like this. And then, that's not going to change. This one changes. It's, oh, had it almost. Yep. See that 20 over there, 20 in there? That's the one we have in the question. Oh, no, I just messed it up. Okay, so let's get to the questions. Angle ADC. Let's clear this clutter. Okay, it's a bit messy at the moment. I'm going to leave the angles. Alright, so angle ADC, meaning we're going from A to D to C. And I already told you that one, wasn't it? 49, because opposite angles in a cyclic quadrilateral adds up to 180. So that one will be 49. Okay. Angle AOC. Let's take that away. Let's look at AOC. AOC. Okay. What have we got here? An angle at the center. What do we know about angles at the center? Let's go look at that. Okay. Where are they? Over here. Ooh. That's not what I want. Angles at the center. See, this is what we got over here. Let's get a nice round. Let's make it a nice round 100. What do you notice? Do you notice there? It's all because of the arrowhead theorem. That the angle at the center is always exactly twice the angle on the circumference. Half of 100.8, 49.7. Double 49.7? No, that's not right. Yeah, it's slightly off. This program is not perfect, is it? It's supposed to be double. Okay. You get the idea. Okay. Angle at the center is always double the angle on the circumference. Okay. It's like I'm having fun. 90. See, that should be 40. No. It should be 45. This program has gone haywire. Okay, that angle there should be 45. Okay, yeah, now it is. Oh, this is that one's not good. Do you know what I mean? Got it. Same with the angle in a semicircle. See, now the angle of the semicircle is 180. With a straight line, the angle of the circumference is 90. Okay, so I hope you got that one. Although, okay, so that means always look very carefully at where the angle goes from. So, right, A goes to O, A also goes to D. C goes to O, but C also goes to D. So that's what we got. All right. In this case, our theorem looks a little bit different. Looks more like that. Okay, and then I think it was 49. 49 is the angle on the circumference. So that means the angle at the center is double that. So you need to do 49 times 2, which will give you 89. No, it gives you 98. My goodness. It gives you 98. Which I think will be a good time to check the mark scheme. 49 the first one, 98 the second one. Look at this. Follow through from your previous answer. So if you got this one wrong, yeah, doesn't matter what you wrote here. If you double that and write it there, you get this mark. For a 50 here or 100 here, get the second mark. Okay, that's what a follow through is. All right, let's go to angle BAT. B-A-T. So, it's good. You're allowed to use your highlighter and colors even in the question part in your exam. Just do not use it where you write the answers. But here in the exam, it's very good to highlight things, to make things stand out. So they want angle BAT, which is B-A-T. You see I already wrote the answer in there because we looked at it earlier. Okay, because here we got an angle of a triangle there. So the angle between the tangent and the triangle here is equal to the opposite interior angle, which would give us 20. Okay, remember that one here. So this is the one. Shows it a bit clearer. Just need to make this 20 or 20.2. Get the idea. That's what we're seeing there. Okay, and so that means this one is 20 degrees. And then we got angle OAB. So let's clear that. Angle OAB. This one over here. Okay. OAB. So what do we know? You remember that the angle between the radius and the tangent is 90. But we already got this one here, which is 20. This is 20. So all we need to do is 90 minus 20. The answer, of course, is 70. This one here will be 70, the one that they're asking. Okay. Hope that was clear enough. So 70. Check the mark scheme, 20 and 70 for those last two. Okay, again, follow through mark. So it is your previous answer, which is 20, but you got it wrong, you wrote something else. If you subtract that from 90, so if I wrote 30 for question C, and then I write 60 for question D, I can get a follow through mark for question D. Alright, sometimes if you don't know what an angle is, just make it up and then work out the next one. You know, you get a follow through mark. Alright, circle theorems is definitely something you need to study. Okay, I used here Desmos, but there are many places to study these, and they're not even all there. Question 14. We need to make y the subject. At the moment, actually nothing is the subject, because the h, if the square wasn't there, the h would have been the subject. But anyway, now we look at the y alone. Alright, so let's write this down again. We've got h squared equals x squared plus 2y squared. Means we just need to get rid of everything. So the y is by itself on the, well, let's make it the right hand side of the equation since it's already there. Okay, whatever method you use, the balancing method, you do the same on both sides, or you're moving things across, the effect is going to be the same. We need to get rid of that x squared, so we move it over there, we subtract x squared from both sides, we will have h squared minus x squared equals 2y squared. Why do I start with the x squared? General rule is just start as far away from the y as possible, but also if you have to work backwards, right? If y was a number, the first thing that will happen to it, bit mass, we would square it, then we'll multiply it by 2, and then we'll add x squared to it. So you work kind of backwards. So you start as far away from the y as possible. That means we're going to get rid of this 2 next, which means we need to divide both sides by 2 or move it to the other side and divide that 2 on the other side. So we're left with the y squared. Only thing left now is get rid of that square. Again, square root both sides or move it to the other side and then square root, which would be then the square root of h squared minus x squared over 2. There are other ways to write it. You can put square root above and below the line. I'm pretty sure that will do the job. Yep. You subtract the x squared, do this, divide the 2, do the square root. Plus and the minus is just that when you square root a number, you got a positive and negative. It's in block brackets. It means you don't have to have it. If you don't have it, you won't lose a mark. Okay. So you get a mark for every move you make, basically. For every correct move. 1 mark for making that move. 1 mark for making that move. And then 1 mark for doing the square root. Okay, just make sure you do them in the right order. Question 15. The moment you see these words, correct to the nearest, that means bounds. It means this number here has been rounded. Okay, there were more digits. They want to know what those more digits are. Okay, the trick is here, correct to the nearest answer. You take that thing there, okay, the 5. It might be the nearest whole number, and you take 1. It might be to 1 decimal place, then you take 0.1. It might be to the nearest 10, then you take 10, or the nearest 100, you take 100. You take that thing that's been rounded to the correct nearest, and you divide it by 2. Which gives us 2.5. And then, to get the lower bound and the upper bound, you add or subtract. Lower bound, you subtract that, which will give us 172.5, and for the upper bound you add that, which will give us 177.5. That just means that they have rounded it to the nearest 5, so the number is somewhere between 172.5, which if you round it to the nearest 5 will go to 175, and 177.49 recurring. Okay, but in bounds we write 177.5 as the upper bound, as they want, but remember that is not included. It means actually anything slightly smaller than that, but that's what we write. Let's see what the mark scheme says. Yes, be careful for 177.49 recurring. Lots of students wants to write that but remember, if we actually write the bounds, we write it like this with the less than sign, whereas the other side we write it with a bigger than or equal to sign. Okay, so that upper bound, don't complicate things. We know that 177.5 to the nearest 5 will actually round to 108, but because when we write bounds we use the less than sign and not equal. Okay, so be safe, stick with 177.5, not 49 recurring. Okay, again, Raphael's height 161, correct to the nearest. You can put a little 1 in there, 1 centimeter. We take that 1 centimeter, we divide it by 2, we get half a centimeter. Okay. Okay. So this times now, Raphael, his lower bound will be 161 minus 0.5, which is 160.5. And his upper bound would be 161 plus half a centimeter, which would be 161.5. Okay, now they say work out the upper bound of the difference between Ella's height and Raphael's height. Okay, so normally the difference, you'll say 175 minus 161 is, what's that, 14? 14, okay, but that's not what we should be doing here. And then don't do that and then work out the bounds. Now you need to use the bounds answers, right? So we need to use this, or this, and then that, or that, to get, in this case, the biggest possible answer. Okay. Now with adding and multiplying, questions like this is very easy. You want the biggest answer, you take the biggest two numbers. You want the smallest answer, you take the smallest two numbers. But with subtracting and divisions, things is a bit more weird, okay? Because now we want the biggest possible answer. If we just take the two biggest numbers, 177.5 and 161.5, what are we going to end up with? We're going to end up with, what is this? Well, 777 minus 61 is 16. Which looks good. Okay, but that is not the biggest possible answer. Okay. It's not the biggest possible answer. Because if we take the biggest possible number we have, which is the first one, and we subtract the smaller one from it, we end up with even a bigger answer. So 0.5 and the 0.5 minus 177 minus 160 is 17. You see, that's a bigger one. Okay? And that's the biggest possible answer we can get. Okay, so the rule is, if you want the lower bound, when you multiply or add, you take the two lower bound answers together. Or you want to work out the upper bound, you take the two upper bounds. Okay. But when you are subtracting or dividing and you want the lower, you want the smallest possible answer, you take the smallest possible number you have and you subtract from it, or you divide through it, the biggest possible one you can, the upper bound. And then for the upper bound, it's the other way around. You take the biggest possible one, the upper bound, and you divide it, subtract from the lower bound. Okay, so this is the one you need to be careful with. So my answer is 17. Let's check. 17 it is. Okay, you get a method mark for subtracting 160.5. So it's quite tough here, it seems. If you subtract 160.5, 1 mark, no matter what you subtract it from, and then full marks if it's 17. That's what they say. Okay, not very friendly, are they? Okay. Moving on to question 16. For question 16, I've gone to the whiteboard. And we need to draw suitable lines and shade the unwanted region. Of course, it's always going to be an unwanted region with shading. Okay, so first line here. Let's look at x equals 2. Alright. X equals 2 will be a line that on the x-axis goes for 2 upwards. So that will be a vertical line, always in line with x on 2. If you go to the right or left, x is not 2 anymore, but you can go up and down. So what you need to do here is you need to get your ruler out, and I strongly recommend using a pencil, especially in these questions, because one mistake and everything becomes a mess, and you draw a line there. Okay, so I'm gonna say this is the line. X is bigger than or equal. Because it's equal, it's a solid line. Of course, if it was just bigger than, you make a dotted line. Alright, so bigger than means we want what is to the right of that line. We do not want what's to the left. Okay, so we always put in darkness what we don't want. So you will be shading in the left hand side of that. Okay, which is this part here. Okay. And shade it nicely, right? Examiners, they want to see a little bit of effort. Then they'll be nicer to you. They see you put a little bit of effort in. Okay. Let's switch some color here. Alright, next one. y, think of the line y equals x. It means y and x is always the same. If y is going to be 0, x is going to be 0. If y is 1, x is 1. If y is 2, x is 2. That's the line where they're always the same. So it's a diagonal line. Be careful with diagonal lines if the axes are not the same. It's not going to be exactly diagonal. But make sure you go through the points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Don't always just draw a diagonal line. In this case, our x and our y axis is the same. So it will be a perfectly diagonal line. And again, it's a solid line because it is bigger than or equal. Okay. To shade the unwanted region, just let's look, yeah, what is unwanted? Look at the coordinate here, for example. This is the coordinate 4, 6. Okay, what is bigger? The y is bigger. We want the y is bigger, okay? So we're not going to shade, we want that. Okay, we're not going to shade that. All right, look at the point here, for example. This is the point 6, 3. Now the y is smaller. We don't want that. It tells us the y should be bigger or equal to x. So that means we do want to shade that part. So we're going to do that. Pick a green. So you do want to shade below the line. Right, last bit here. 2x plus y. Look at the line 2x plus y equals 8. There are different ways to sketch that. For me, the quicker is just make the x 0, which will give us 2 times 0 plus y. 2 times 0 equals 0, that means y equals 8, means that line will go through 8 on the y-axis. We make the y 0, so that will give us 2x plus 0 equals 8, which means 2x equals 8, which means x is, just divide the 2, x is 4. On the x-axis, it will go through 4. Bam, that's all you need. You can put in some coordinates there as well if you want. You like make x 1, so, and then subtract it, you get 1, 6. Okay, and you can get all the coordinates on that line. But that is for me the quickest. So let's draw the line. Again, it is, what is it? Oh, the ruler's gone. Less than or equal. So the equal again means we're drawing a solid line, not dashed. There we go. And then where do we shade? Let's think about this. So it is less than or equal. So we want less than, not only to the bottom, to the left. That's what we want. But you can always pick a coordinate. Let's pick this coordinate. This is coordinate 4, 6. Okay, put it into 2x plus y less than or equal to 8. So the point 4, 6. The x is 4, the y is 6. Put it in there. So that's 4 and that's 6. 2 times 4 is 8. 8 plus 6 is 14. Is 14 less than 8? No, this is wrong. That coordinate is in an unwanted region because it makes the inequality wrong. That's how you know where to shade. If I put in another point here, for example, the point 2, 2, which is below the line, and I put for the x a 2 and the y a 2, 2 times 2 is 4, 4 plus 6, 6 is less than 8, that is correct. So that point there is below the line. We don't want to shade it for that line because it is in the wanted region. Okay, so that's why you double check where you want to shade. So that makes it clear we want to shade everything above the line over here. Okay, try not to go over the line. Bam, there's the answer. Okay, let's see what the mark scheme has done. Of course, yeah, you put the R, and then they've got a quite complicated, okay. Question B, the point P lies in the region R, the coordinates of P are A and B, write down the largest possible value of A and B. So we just need to go to the region R and look carefully. Okay. What is the largest possible value for A and B? Could it be this point here? Because remember, we can be on the lines is included, which is the point 2, 4. The largest support for A plus B. So that is it. 2 plus 4 is 6. What about this point here? You see, they provided small squares there, so they want you to be quite accurate. They did not say it's integers, which means we can have 2.6 and 2.6, but that will give us 5.4. So I think that's the biggest one. So 2 and 4 gives us 6. Just go the highest up, Okay. For A plus 4, that's 6. No, shouldn't be in red, should it? Anyway, there you go. 6, yes, that's it. Nice. Question 17. Similar triangles. That just means everything is they're exactly the same triangle. Angles are exactly the same size, but the triangles are different sizes, but they are in a ratio. Here you can clearly see that the first triangle, ABC, the line AB is 6. That corresponds to the line PQ, which is 12. So that means the second triangle is just twice as big. So we have a scale factor here of 2. Okay. They tell us that the area of triangle A is 15 centimeters square. So what is the area of triangle B? Now be careful here. 6 centimeters to 12 centimeters, that is a linear scale factor. Because we're talking about centimeters here. But if we do 15 centimeters square, how many centimeters square? We need to square the scale factor. Yes, so we need to multiply it by 4. And if it was volume, we would have had to cube scale factor, and that means multiply it by 8. 15 times 4, that's easy. Double it again. We got 60 centimeters square. Straightforward question here in that sense. 60 is the correct answer. They show here, my favorite method actually is because you always write it as, we got P over Q, so that's 12 centimeter over 6 centimeter equals, now we put the bigger one over the smaller one, so we want to know what this one is in centimeter squared. Let's call it X over 6 centimeters squared. I write the units, though, as you can see the units are different, which means we need to square this. So in the end you're going to do 12 over 6 squared times 6 will give us X, which is going to be the same. Isn't it? 2 squared is 4, so give us 24. Oh, because of course this is 15. My goodness. Then you'll get the same answer, which is 60. That's what they refer to. Okay, so they don't say or equivalent. So using this method on the right seems to be Cambridge's preferred method. Although a lot of people find my method easier. Whatever you find the easiest, that's the one you use, okay? So again, here we go to volume. Okay. So now remember the scale factor is still the same. Like I said earlier. The linear scale factor being 2. Now if we make this a prism, Okay, and they say the smaller one is 300 centimeters cubed. Bam. What is this one? Centimeters cubed. Okay, so the method I explained was if we go from 6 centimeters to 12 centimeters, when it is centimeters square, when you square the scale factor, you get the area scale factor. So now when we cube it, we need to do the cube the linear scale factor, which is 8. So we need to do 300 times 8. 300 times 8 is easy. 3 times 8 is 24. And then we add the 2 zeros, centimeters cubed. The method I've seen on the mark scheme refers to you write it as a ratio. So you write 2 over 6 centimeters. We want to know, let's call this x, centimeters cubed over 300 centimeters cubed. So you notice that the units are different, which means we'll have to cube this one. Okay. Which will give us 12 divided by 6 is 2 cubed, and you multiply the 300 on the other side, which will give us the same thing. Okay, but pay attention to detail, because I wrote that on the line and then I noticed, wait a minute, there's no cube there. Something's going on here. Okay, and that's when you go back to your question and you reason, I said calculate the length of the larger prism. So we're in here for some trouble, I can see. Okay, so we now know that this is 2,400 centimeters cubed. How do you work out the volume of a cube? Well, you need to do half base times perpendicular height times the length. We don't have the perpendicular height, but we do have is the area of the front face. Okay, so the area of the front face, which is this, which you see as centimeters square. If we were to multiply it by the length, which is centimeter, we'll get the volume. Okay, that's the definition of the area of any prism. You can take any prism, doesn't matter, prism is a 2D shape. You make it into a prism, you want to get the volume, the area of the front face times the length, because centimeter square times centimeters will give you centimeters cubed. Okay, that means 60 centimeters square times the length will equals 2,500 centimeters cubed, or rather 2,400 centimeters cubed divided by 60 centimeters will give me my answer in centimeters. So how do we divide 2,400 divided by 60? First we can cancel those zeros, then we can say 24 divided by 6 is 4, and there's still a 0 hanging around, so that's 40 centimeters, which sounds like a good reasonable answer. Okay, just make your handwriting clear. So pay attention to detail, and that it is 40. Okay, they seem to have a different method from mine here. They worked out the ratio between those two. They worked out the length. Smart people. The mark scheme tells you first you work out the length of the smaller one. 300 divided by 15 is 20, and the linear scale factor being 2, you just double it, you get 40. That's a lot easier. Well, I still like my method more. Question 80. Now we're getting into the tougher stuff, yeah? I don't know what's going on here. Let's draw a picture. Let's use our pencil. A cylinder. with a radius of 2 and a height of h has the same volume as a sphere. You know what a sphere is a ball. Oh, a sphere, it's got like a little shiny bit there, with a radius of 3 centimeters. We need to find the volume of that sphere first. Okay, what is the formula for a sphere? I can't remember, but these days they give it for us on the formula sheet. Volume of a sphere, 4 over 3 pi r cubed. 4 over 3 pi r cubed. So the volume of a sphere is 4 over 3 pi r cubed. We don't have a calculator. Are we going to do pi? Okay, let's just do what we can. So it's pi times 3 cubed. What is 3 cubed? 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So I'm going to just put the pi at the back because it just annoys me. So this will be 27 times 4 over 3 times pi. How do you multiply 27 by 4 over 3? Well, you just divide it by 3. Just like it's 27 over 1. 27 divided by 3 is 9. 9 times 4 is 36 pi. The volume of this sphere is 36 pi centimeters cubed. Okay. Things are going well, I think. Definitely got some marks by just using the formula, knowing how to multiply fractions. Okay, that means the volume of this one here is 36 pi. How do you work out the volume of a cylinder? I remember this one, but let's check if it's on the formula sheet. Volume of a cylinder, there it is. Pi r square h. Pi r square h. Pi r square h. So the volume of a cylinder, which we have, is 36 pi, equals pi r squared. That's just the formula for the area of a circle times h. We know the radius of that cylinder is 2, so it's pi 2 squared, which 2 times 2 is 4. Just put the 4 in front, because we always put the number and then the symbols and then the letters. So we want to know what h is. We just need to divide both sides by 4 pi, or divide the 4 pi on the other side. So 36 pi divided by 4 pi. And that means the pi's, they cancel each other. 36 divided by 4, 9. Height is 9. Check. 9. Told you so. Look at how complicated they make it look, but this is just exactly what I did here. So look at my explanation, it's better. Okay, I guess you get a mark for this, for that, for that. But probably using the formula. Okay, yes, or equivalent. The mark scheme is crazy. Okay, a solid metal cube has sides with length 20 centimeters. Let's draw that. A metal cube. This is 20, that's 20, that's 20. Okay. The cube is melted down and made into 40 solid spheres, each radius r. My goodness. What the hell? Okay. What is the volume of this cube? That's length times width times height, okay? So the volume of the cube will be length times width times height, which is 20 times 20 times 20, or just 20 cubed. So 20 times 20 is 400 times 20. You know what? There's 2 times 2 times 2 is 8. And then there's 3 zeros. 8,000 centimeters cubed. Okay. Now we got 8,000 of liquid metal flowing very hot, and we then boil. I guess you've got little molds, and you put in those little molds. You got 40 little squares. So how much is each? What's the volume of? Is that 40 little of one little sphere? One little sphere, which is 1 of 40. We need to divide. So we need to do 8,000 divided by 40. Right, we can cancel a 0 and a 0. We can say 8 divided by 4 is 2, and there's still 2 zeros hanging around, 200 centimeters cubed. That will be one little sphere. Right, so we need the formula for the volume of a sphere again. What was that? The volume of a sphere. It's on the formula page. We used it before here. 4 over 3 pi r cubed. Okay, what do we have in that form? We got the volume of one sphere, which is 200. No need for the units there. Right. What do we do next? Well, we need to get the r, make the r the subject, get a line. So move everything. So first thing I'm going to multiply the 3 over there. So it could be 200 because it's divided by 3. We times it by 3. So we left with 4 pi r cubed. 200 times 3, of course, is 600. Then we're going to divide the 4. So 600 divided by 4. What is 60 divided by 4? You know how to work that out? Dividing by 4 is very easy. You half it, then you half it again. Half of 60, 30. Half of 30, 15. But there's a 0 hanging around, which gives us 150. And that's now when you start getting happy, because there's 150 there. And we all left to do. Show every step here, yeah? You divide the pi. And then you cube root, and that's the answer. This is 0. Okay. The questions that say show that, you need to show stuff, man, as much as you can. You want your marks. Don't skip anything. Okay. You see how complicated it looks here? Yeah. This is the questions that the examiners spend the most time on going on through step by step by step. And the more you show, the better your chances of getting your marks. Okay. Show means show. Okay. Question C. A solid cylinder. They like to up the game, don't they? Solid cylinder again. This time the radius is x and the height is 7x over 2. The surface area of a sphere, they can't get away with the spheres and the cylinders. With radius capital R is equal to the surface area of the cylinder. Of course, man. Now, remember, cylinder is a rectangle and 2 circles. But do they give us the formula? The surface area of a cylinder. The curved surface area of a cylinder. They give us that. Okay. The curved surface area. But that means that's just a rectangle, man. That's the curve. You fold it, you got the curve, like a pipe. Okay, but remember, a cylinder that's closed off, it's got 2 circles attached to it, like a lid and a bottom, and that would just be pi r squared, because that's the area of a circle. So if you want this whole surface area of a cylinder, you need to add the area of a circle twice. 2 pi rh plus 2 pi r squared. Yes, so that's what we're going to have to do now. There we go. So, I have no idea how to do this question. It's the first time I've ever seen this. I'm just going to fly at it, right? So, the surface area of a cylinder is 2 pi RH plus the 2 circles. Right, so you see they say total surface area. Yeah, very important. Details. Okay, so what is that? What do we have? We got the pi stays the same, the radius being x and the height being 7x over 2 plus 2 pi, and the radius is another x squared. Okay, what can we do here? So, when we multiply this together, this 2 and that 2 will cancel. The x times the x will give us x squared. And there's a pi. We can squeeze that together. Plus 2x squared. You see what x squared there, and a pi. Now we can simplify this because the terms are exactly the same. I got 7 pi squares and h's. It's like I have 7 apple pies and a pear, and I got another 2 apple pies and a pear. You know what I mean? It's the same. Apples and apples, pears and pears. Add them together. 7 of them plus 2 of them gives us 9x squared and pi. So that's the surface area of the cylinder, which is equal to the surface area of the sphere. What's the surface area of a sphere? Oh my goodness. Go back to the formula sheet. There's no tricks here. Curved surface area of a sphere. There we go. 4 pi r squared. 4 pi r squared. 4 pi r squared. 4 pi r squared. So the surface area of a sphere is 4 pi. Remember, this case it's r squared. Okay, and these two things are the same. They are equal. So that means 4 pi r square equals, you know what I'm going to do? I'm going to swap those two around. You can do that. 9 pi x squared. So the first thing we're going to do, we're going to get rid of that 4 pi, which means we divide it on the other side. The 2 pi's will cancel. Don't forget the square. So we're left with 9 over 4x squared, and then we just need to square root that. So it's square root 9x squared over 4. And you know, ladies and gentlemen, what is the square root of 9? 3. What's the square root of 4? 2. What's the square root of x squared? X. And that's my final answer. 1.5x, or 1.5x, or 3 over 2x, or 3x over 2. Doesn't matter. I'm going to write it like this. Or you can write it like this. Or you can write it like... Don't write them all. Write one of them. Let's see what the mark scheme says. Oh, yeah. They only gave those 3 options. Look, I've got one here with a 3 over 2, the x at the back. I'm sure they marked that correct. Okay, but my first, oh yeah, that was the best one. Okay, right, again, the marking is quite complicated here, but I can pretty much show if you use the formula correctly, 1 mark. if you manipulate it correctly. It's only 3 marks. They're quite tough, man. Quite, especially with the marks. Okay, but you can do this. Just take it slow, do what you can. Alright. It's never gonna end. Question 19. Find h. So we got functions here. You see they got function of h. Let's make this a bit bigger. Alright. So they've changed the x for a 3. So we change that x for a 3. So h3 will be 4, 3. So what is 4 cubed? 4 times 4 times 4 times 4 times 4. 4 times 4, 16. And we times by 4 again. 4 times table is so easy. Just double it. 32, double it again, 64. Remember that, 4 times table. Double, double. 64 it is. Okay. Then the function of f, the function of g, 1. So, we need to first write down the function of f. Okay, which is 3x plus 2. Now, I've stretched out, made some space here, because then instead of x, we need to write the function of g, which is x squared plus 1. So instead of x, we write x squared plus 1. Okay, and then instead of x, we put 1. So fg1 equals 3, 1 squared plus 1 plus 2. So 1 squared is 1 plus 1 is 2. 3 times 2 is 6. Answer is 8. Yes, so it is. And yeah, you see how I wrote that there? That's 1 mark. Or even the simplified bit. So, I mean, you seem to want to see this. And then that. If you write on the function of f, you put g in it, and instead of x, you put 1. Easy. Okay, same thing here. Don't be scared of all that. It just tells you it's going to be quadratic. Okay, so we write the function of g, which is x squared plus 1. X squared plus 1. So that's g. And instead of x, we put the function of f, which is 3x plus 2. So rub that out. Put 3x plus 2 squared. Okay, so this is expanding brackets. 3x plus 2 squared means we've got 2 of the same brackets, and just for fun there's a 1 hanging around at the back, don't lose it. So 3x times 3x, 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. 2 times 2 is 4. And now we can simplify it. So it's 9x squared. 6x plus 6x is 12x. 4 plus that 1. Wait, this moment has come. That's 5. So 9x squared plus 12x plus 5. Do take this slow. It's so easy to make a mistake here. Which I didn't. It's good. Okay. And 3 marks. 3 marks. Seems like if you got this, expand the brackets correctly, and the final answer. Don't make any silly calculation mistakes. You don't want to lose. Alright, like when you're adding instead of multiplying. Yeah. Okay. Right. Function of f, x. So we take the function of f, 3x plus 2. So function of f, 3x plus 2. Then the function of g is x squared plus 1. But they told us x for g is 7. So 7 squared is 49. You add that 1, you get 50. We subtract 2 from both sides. We get 48. And we divide 48 by 3. What's 48 divided by 3? 16. Do you know how to work that out quickly? I don't know really. You can always do the bus stop method. 3 goes into 4 once, remainder 1. 3 goes to 18 6 times, for example. Or maybe you just know it. You don't. Okay. Question D, the answer is 16. There we go. Show your steps, ladies and gentlemen. Because we get 48 divided by 3 wrong, and you don't show any steps, you get 0 marks. So be very smart to show that step. Okay. And you make less calculation mistakes if you show every step. The inverse of f. F is 3x plus 2. There are different ways to do this. So if f is 3x plus 2, it's kind of just like changing the subject, right? You can make function y, put it equal to y, and then just rearrange. Subtract 2 from both sides, and then divide the 3. When you write your answer, change the y back to an x. Another way to do this is say, like, look what is happening to x. It's being multiplied by 3, that's why it's 3x. And then you add 2 to it, which is 3x plus 2. So you can do the same. You take the x, you subtract 2, that will give you x minus 2, and then you divide it by 3, that gives you x minus 2 over 3. That's another way of doing it. Okay, either way. X minus 2 over 3, or equivalent, final answer. I don't know what else is equivalent to that. Okay. Alright. They have some weird steps here, but anyway. Okay. So, question F, things are starting to heat up a little bit, but we can handle it. Gx, the function of g. What is that again? X squared plus 1. Over the function of f, 3x plus 2. And if for some reason there's an x who decides to hang around. Okay, now we got a fraction here. I'm going to write a single fraction, so we're going to have to add things together. Let's make this a fraction. Put it over 1. Okay, now we need to get the denominators the same. Okay. There are different ways to explain this, but the easiest, man, is the smiley face. You multiply the two denominators the same. You multiply this at the top there. You multiply this at the top there. Okay, smiley face method. So 3x plus 2 times 1 is easy. It's 3x plus 2. 1 times x squared plus 1 is x squared plus 1. Little trick comes here. There's a plus, remember, between them. There's already an x, so everything here, 3x plus 2, needs to be multiplied by the x. Okay. Now we just need to simplify this. Alright, so x squared plus 1 stays there. 3x times 3x, 3x squared. X times 2 is 2x. Still over 3x plus 2. Don't be lazy writing these things down. So there's a 1x squared we can add to the 3x squared. That gives us 4x squared. There's a 2x. And there's a 1 over 3x plus 2. How many marks is this? 3 marks. Was in terms of x in its simplest form. Do you think, can we factorize that 4x squared plus 2x plus 1 and then cancel it below that 3x plus 1? I don't think so. I think that's the answer. Yeah, that is the answer. Okay. If you can factorize it, like make 2 brackets, and where one of the brackets is x plus 2, they can cancel. That's not what's going on here. Right, fine. Question 19G. Right, the original function of h, x, was what? What was it? 4 to the power of x. Alright, now, if you do watch other videos, they often try to explain this with logarithms, but that's not on your IGCSE curriculum, so you shouldn't be knowing about anything with logarithms. So the best way I can try and explain this is if we change this to y equals 4 to the power of x, and we want to do the inverse, we swap those two around. So x would be then 4 to the power of y, where y was the 2. So that means x is 4 to the power of 2. You see, the fact, the 2 would be the answer, would be the output that you get. But when you do the inverse, which the inverse is at this moment here, it swaps around. It becomes the thing you put in there. See, the thing you get out becomes the thing you put in. Anyway, and that would be 4 squared is 16. Hope that makes sense. It's kind of just swap it around. Yeah, that's explaining about logarithms. You don't have a calculator to do that anyway. 16 is the answer. Moving on to question 20. Right, they tell us that b is 2 to the power of 10 times 3 to the power of 8 times 7 to the power. This is a massive number, but I've broken it down into prime numbers. It means b is 2 times 2 times 2 times 2 times 2 times 2 times 10 times 3 times 3 times 3, 7 times 7 times 7. Alright, so what can we do to figure this out? Okay, let's see what there is. First, I'm going to deal with the p squared. Okay, so if p equals that, then p squared simply means we got all of that twice. Let's think of an easier example here. If I got 2 cubed, okay, and I say I'm now going to square that. What do I have actually? I've got 2 cubed, that's a 3, times 2 cubed, which will be, remember your indices rules, 2 times 2 times 2 times 2 times 2 times 2, 2 to the power of 6. You add those little numbers together. Okay, or you could say I did 2 times 3, which is also 6. You see that? So that's what we do here. We just have to basically double all the powers. So if p is all of that, p squared would be 2 to the power of 20, 3 to the power of 16, and 7 to the power of 10. Okay, sorted that little square now. Then there's a 12 in front of it. Okay, so if I want to put a 12 in front of it, it means now I'm doing 12 times p squared. So let's do the same on the other side, and we're doing 12 times 2 to the power of 20, 3 to the power of 16, 7 to the power of 10. But what is 12 as prime factors? Alright, you know how to do this the different ways. Divide 12 by prime numbers. First prime number there is 2. 1 is not a prime number, 2. So 12 divided by 2 is 6. We can divide by another 2 again, which is 3, and then there's only 3 is the last prime number. So 12 equals, so I equal that. 12 equals 2 times 2 times 3. Or let's write it over here. So 12p squared would be 2 times 2 times 3 times all those other 2's and all those other 3's and all those other 7's. Alright, so we just need to add these two to those two. So there's two 2's added to these 22's. We now have 22 2's. Add this one 3 to the other 3's. So we're going to have 16 plus 1 is 17 3's. And then we got 7 to the power of 10. So write 12p squared as a product of prime factors. So 12p squared. A product means we multiply them together. Oh my goodness, I'm really struggling with my handwriting today. Okay, 3 to the power of 17 and 7 to the power of 10. Let's check that mark scheme. Yeah, that's what it is. Got it right. Okay, so you get 1 mark, well, for either, right? Get 1 mark for either doubling everything like that, or by getting 12 equals 2 times 2 times 3. That one or that mark, and then a mark for the final correct answer. So 2 out of those 3 marks, not 3 marks. Question 21, vectors, my favorite. That and Venn diagrams. Right, so again, let's go through all the information very slowly. In the diagram, O is the origin, so that's like where you start from. OT is twice TD. Okay, so it means we can say that they've divided this into 3 parts. You see that? This will be 1 part and this will be 2 parts, because this OT is twice as big as TD. So we can actually say this is 2/3 and this is 1/3. Does it make sense? Because if TD, you need to double it to get OT. See? So we got a little TD here, a TD there, and a TD there. 2 TDs here, 1 TD there. Okay. M is the midpoint of TC. Now that's easy. Midpoint means we got a half of TC there, half of TC there. Okay, and they tell us more stuff. This is OC, going from O to C in this direction. Direction is important with vectors. They call this little c. And then from O to D, going in that direction, they call that little d for the whole line. Okay, the whole line there. That's D. But now we already know they've chopped that up into 3 parts, where this is 2. So this is 2/3 D, and that's 1/3 D. Together it makes 3/3 D, which is a whole D. Whole little d. Okay. Find the position vector of M. This is now where I like to swap colors. Okay, so position vector is we need to travel from here to there. Okay, problem is we don't have any clue what that is. So we need to pick a route that we do know. There are 2 of these routes. Okay, you can pick any one. I'm going to make one route green, so we can go along C here, and then go up that way. Okay. And then we get to M. Or, let's use purple, we can travel along D here, and go down that way. Alright. They should both work. Which one are we going to pick? Okay. Why don't you vote in the comment section? Green or purple? I'm going to go with green. Looks a little bit easier. There's fractions involved. We have a problem though. We don't know what is this line here, which we call TC or CD. Okay, so we first need to figure that out. So let's start over. Okay, I first need to figure out what is TC or CT. We need to pick a direction. Which direction? Well, we wanted to go to, I'm gonna pick it in this direction. So we need to figure out what is CT. Okay, going in that direction. From there to there. Can't go like that. Okay. So we need to travel along here. Which is the opposite of c. So that will be a negative c, and then there. See, we end up in the same place. And then we go right with that one, so that will be plus 2/3 d. Got that? Or we can swap it around. We can say it's 2/3 d, as long as it stays positive, minus c. Yeah, that is what CT is. So, if we go back now, remember we wanted to do green, or we wanted this route from O to C and from C to M. Okay, so that means, and it's always smart to write down the route you take. I'm gonna go from O to M, but to get that, I'm gonna have to travel from O to C, and then from C to M. This could possibly get your mark. We'll check the mark scheme now. Okay, so that means that's what the position vector of M is from O to M. So what do we know? Well, we know that OC is little c, and we know that CM is only half of that line, which is CT, which we said is this over here. So half of 2/3 d minus c. I don't know if this is the best way to do this question, but it will work. So c plus, what's a half times 2/3? Easy multiplying fractions. Multiply the top with the top, with the bottom with the bottom, or just cancel the 2's, so that will be 1, there will be 1/3. So that will be 1/3 d, and then a half times minus c will be minus a half c. Not finished though here, because there's a c here, a c there. We can say this is a 1c. 1c minus a half c, of course, gives us a half c. And the 3rd d is hanging around. Now, I believe that's my final answer. Half c plus a 3rd d. Let's check the mark scheme. Half c plus a 3rd d. Final answer. Okay. Right. There are different ways. So you see here, method mark for correct route. So if you don't have any of that stuff, okay, you can get a mark for just showing this, saying I'm following this route. Okay. And then you can get a mark, for example, for that. And for that. Well, there's more than one way. You could have gone the other way as well. Maybe you've done that and you should get the same answer if you go the other way. Alright, so we do this slowly, carefully. You'll get it right. Question 22. Seems like they want to make y the subject. So it means you just need to get rid of everything around y. The cube root and the square. So let's write that down. So it's cube root of y squared equals root 6 of x. First thing, let's get out our cube root. How do you get a cube root? Well, you just cube it. They will cancel each other out. Of course, it's an equal sign. It needs to stay balanced. What you do on one side, you have to do on the other side. So we need to cube this. So what happens if you cube a root 6 on the left? Okay, so on the right, I mean. On the left now, the cube with the cube is opposite. They cancel each other out. What's going on here? Now remember the rules of indices. That the rules are with the roots. If, let's make this a, right? You can write any root as a fractional index, and that a goes below the line. Okay, which means we can write this as x to the power of 1/6. What's another rule of indices? If you got a power to a power, what you do with them? Well, you just multiply them together. So what's 3 times 1/6? 3 times 1/6. Remember, you can put this over 1 and then top with the top. 3 times 1 is 3. 1 times 6 is 6. Simplify it to a half. Okay, so we now have y squared equals x to the power of a half. Now, get rid of that square. How do we get rid of the square? Well, we can square root it. So we do the same here. Square root this. So it's y. This will cancel. Remember, a square root has a little 2 there. We just don't write it. Okay, and this means we will get x to the power of a half to the power of a half. Again, yeah. So a half a power to a power, we multiply them together, is 1/4. So here we go. That will be x to the power of 1/4. Now we want it in this form. So we just do this rule of indices, the top one backwards. That means we can write 1/4 as root 4. Okay, that's not the answer though. Okay, it means this equals root 4. So don't make that mistake of writing all of that. Okay, they just want to know what is n, that little n, which will be what we have there, which is 4. Okay, don't lose a mark there for getting the right answer but writing the wrong thing on the line. See, just 4. It's only 2 marks, so you get marks for changing the indices to fractions or showing any step along the way. Okay, I think my method is easier. Not changing it to fractions too early, because that can be confusing as well. Rationalize the denominator. Okay, what's rationalizing the denominator means? It means we don't want any roots under the line. See, done it. I crossed it out, it's gone. Now, of course, it's not that easy, but we need to get rid of any roots under the line. So how are we going to get rid of that? Root 6. Well, if you have a root 6 and you multiply it by another root 6, that's like having root 6 squared, and they're opposites, so they're gone. Okay, so we need to multiply this by root 6. Problem is, if we're going to do that, we'll get rid of the root 6 on the left, but then we also, expanding brackets, have to multiply it by the 1 on the right, and then we'll just end up with another root 6. So how do we get rid of that one? Well, we need to get rid of the 1. And how do we get rid of the 1? Well, we multiply it by -1. Does this look familiar? Okay, it is familiar because we've done stuff like that before. If you remember, what's it called? A complete square. If you do x minus 2, x plus 2, and you expand the bracket, you get x squared minus 2x plus 2x minus 4. Yeah, so we have the 2 middle terms will cancel out, and you'll have this. So now we don't have that. What we do have is root 6. Okay, we have root 6. No, let's do it over here. Okay, we have root 6 times root 6 is just 6. Then root 6 times -1 will be minus root 6. 1 times root 6 is a positive root 6, and 1 times -1 will be -1. Okay, I'm leaving above the line blank because we still need to deal with that 45 over there. But now root 6 minus root 6 plus root 6, there's no more root 6. That's like -6 plus 6 is 0. Let's cancel it. So we live with 6 minus 1, which is 5. Okay, but be careful now, because this is a fraction. Now you know equivalent fractions. If you multiply something at the bottom, you need to multiply something at the top to keep the fraction equivalent. So we're going to have to do the same above the line. We are going to have to multiply 45 with root 6 minus 1, which will give us 45 root 6. We can just write it like 45x minus 45. But you know, this is not a very smart thing to do. I just did. It's better if you leave it factorized like it is. That is a factorized form. Because now we can say 45 divided by 5, which of course is 9. Okay. Which is square root 6 minus 1. Is that the simplest form? Not so sure. What about 9 square root 6 minus 9? Is that the simplest form? Good question. Oh, we're happy with both. Okay, that one or that one. Okay, so you can one for multiplying the top and the bottom by square root 6, then for expanding the brackets. Okay, so 1 mark for doing this, 1 mark for expanding those brackets correctly, and then you can write any one of these on the line. I think the first one is better because then it's just... Okay, so any one of these, this is just 1 mark. Okay, we got a probability tree here. Again, like all questions, slowly, step by step, sentence by sentence. Tanya plants some seeds. Good. The probability that a seed will produce flowers is 0.8. So there's a tree diagram down here. Let's jump to that. Okay, so I think that we now just described this path here. Produce flowers, yes, so it's 0.8. Okay. What does that mean? Remember, in a tree diagram, every branch always adds up to a definite 100% or 1. So this is 0.8, this has to be 0.2. So the probability is only going to produce flowers or not. There's no other possibility. The probabilities needs to add up to 1 or 100%. Okay, so that first part is clear. When a seed produces flowers, the probability that the flowers are red is 0.6. So when it produces flowers, yes, just that it's red is 0.6. That's what they describe in that sentence, that specific path of events happening. And the probability that the flowers are yellow is 0.3. Okay, so remember, the flowers is either red, yellow, or another color. Okay, and that has to add up to 1. So again, 1 minus the 0.6 and the 0.3 would be, of course, 0.1. So all add up to 1. So any other color is 0.1. Tanya has a seed that produces flowers. Okay, so her plant is one of these 80% of plants that produces flowers. Find the probability that the flowers are not red and not yellow. So if they're not red, okay, it means this event did not happen and this event did not happen. So the only event that could have happened is this one here. So the probability is 0.1 or 10%. There you go, 0.1. They don't go for anything else. I don't know if I'm going to take a chance and write 10% or 1 out of 10. Okay, and there it is. Here they don't mind. Or equivalent means you can write 20% or 2 out of 10 or 1 out of 5. I don't know why you want to do that. Okay, just leave it as decimals, but here they don't put or equivalent, which is strange. Okay. Right, so we've done that. Done well. We broke it down slowly. We figured things out. Alright, let's look at part 2. Find the probability that a seed chosen at random produces red flowers. Okay, so that means plant a plant. Okay, one of these lucky 80% and is red. So we got two things there. We got 0.8 and 0.6 because it could have not produced flowers, but it did. Okay, so that's 0.8 and 0.6. Now what do we do with these two numbers? Okay, in this case it's not hard to see. If I'm going to add them together, okay, I'm going to get 1.4, which is impossible. Can't get more than 1 on probability unless it's a percentage, right? Can't get more than 100%, but we work with decimals, so we're obviously not going to add them together. It's multiply. Okay, and that is the rule for tree diagrams. Whenever we move along the branches, right, we always multiply. Whenever we work with the values at the end, we add. So this is multiplying. How do we multiply fractions? Well, we just do decimals. We say 8 times 6, of course, is 48. There is one decimal digit, one digit to the right of the decimal point, and there's one decimal digit there. So altogether, that's 2 decimal digits. We need 2 decimal digits in the answer, so we're going to put a point, and that is 0.48. Can't be bigger than 1 because 1 is definite, isn't it? 0.48 or equivalent, which means 48%, 48 over 100, simplified fraction. Okay, get some follow through marks if you've made a mistake in the tree diagram. Now we continue. Tanya chooses a seed at random. Find the probability that this seed does not produce red flowers and does not produce yellow flowers. Okay, be careful now, because it's not the same as the first question. Okay? Because here they said she had a seed that produces flowers. So we only went for that one option. Now they say she got a seed, so there is still the possibility that her seed may not produce any flowers. Okay, and then if it doesn't produce red or yellow, it could also be producing flowers, but one or the other color. So we got two paths here that we're following. Okay, now remember what I said. When we move along, we need to multiply. So getting a seed from another color, you need to do 0.8 times 0.1. And then it could be a seed not produce any flowers, which is 0.2. Okay, so we got two possibilities that happens here. You get a seed, it produces flowers, but it's one of the other colors. Okay, so again, we do 8 times 1 is 8. There is 1, 2 decimal digits, so we need 1, 2. So we're going to have to add a 0 in there. 8% chance that we get a flower which is not red and is not yellow. But we can also get a plant that is no flowers. Okay, so what do we do with these two values? Well, we're not going to multiply this time, okay, because they show all the possible outcomes, right? You got this one, which is 0.08. If we were to work out the other ones, which is 0.8 times 0.3, which is 0.24, and the last one, of course, was 0.8 times 0.6, which was 0.48. If you were to add all the possible outcomes to this, plus this, plus this, which is the 4 possible things that can happen. If you were to add them together, what would you get? You'll get 1. Okay, so when you're moving along the branches of a trigonometry, you multiply, but if you work with the values at the end, you add them. So we need to do that with these two. 0.08 plus 0.2 is like saying 20% plus 8% is 28%, or 0.28 is the chance for that. So that's part 3. 0.28, or if you work the percentages, okay, yes, you get 1 mark for multiplying them together, and then you get another mark for adding them together. Okay, so 1 mark here, 1 mark here, 1 mark, final answer. You need to know how to work with the decimals as well without a calculator. Okay. Alright, here we go. Again, another question. They're heating things up. So this time, 2 are chosen at random. Okay. And they say, what is the probability 1 produces flowers and 1 does not produce flowers? Let's see what's all the possible things that could happen if you pick 2 seeds. Okay, so let's call this box here seed 1. Okay, yes, it produces, no, it doesn't produce any seed. Okay, let's call this box over here seed 2. Yes, it produces. No, it doesn't. Okay, so what is all the possible outcomes we can get? We can have both producing. We can have seed 2 producing and seed 1 not. We can have seed 2 not producing and seed 1, yes. And we can have both not producing any seeds. Problem with my analogy here is the probabilities are not the same. If it was a 50-50 chance, like flipping coin, this would have worked perfectly fine, but it doesn't. Okay, doesn't. Fine with it. 1 produces flowers and 1 does not produce flowers. So we're clearly going for these 2 boxes, but the probability here is this is not 2 out of 4, because getting a yes and a no, it's got different values. Getting a yes was 0.8 and getting a no was 0.2. Yeah, what do we with the and? The one thing and the other thing needs to happen. Okay, it was like moving along the tree diagram. You have to have a yes and a red, or a yes and a yellow, or a yes and the other color. Okay, you multiply. Opposed to at the end, we can have a red one or a yellow one or other colors that we add. So the and is always multiplying. Okay, so 8 times 2 is 16. We're carrying 2 decimal numbers. So it's 0.16. Okay, but remember there are 2 possibilities. Seed 1, yes. Seed 2, no. Or seed 1, no. And seed 2, yes. So we need to double that. We need to do this twice, or we can just double it. So 0.16 times 2, 0.32 is my answer. There we go, 0.32. So yeah, multiply them together, but do it twice. How do they watermark? Okay, so give things. All right, if you do this once, you get 1 mark. If you do it twice, you get another mark. Final answer. Think carefully with this one. Question 25. Find the value of y when x is minus 1. Right, we've got y equals minus 1. So just put the minus 1 there where the x is, to the power of 4 minus 4 minus 1 cubed. Alright. Be careful here, yeah? Because minus 1 with powers flips back and forth. Okay, if you have minus 1 squared, you'll have minus 1 times minus 1. Two negatives makes it positive, and 1 times 1 is 1. If you've got minus 1 cubed, then you got minus 1 times minus 1. We know that that is 1, just got above, but then we multiply it by a minus 1, so then that plus 1 and the minus 1 will give us a minus 1 again. The moment you put minus 1 to the power of 4, you're going to have now minus 1 times minus 1. It's 1, it's positive. Multiply it by minus 1 again. Now it's minus 1, it's negative. And you multiply by another minus 1, now it's positive again. And that's how it flips back and forth all the time. If the power is a... Why is this not? Work with me, please. Highlight that. If the power is even, the result is positive. If the power is odd, so minus 1 to the power of 5 again, the result will be negative. Okay, so this means minus 1 to the power of 4 will be 1. And minus 1 to the power of 3, minus 4 cubed will be negative 1. Okay, but now minus 4 times minus 1, two negatives, makes it positive again. What means at the end we got a 1. Why did I write a 5? We're multiplying. Okay, 1 times 4 is 4, a minus and minus is a plus. The answer is 5. Whew. There it is, 5. Okay, and look, there's an easy mark here. Just by substituting the values in there correctly gives you 1 mark. But putting the minus 1 where the x is, and then 1 mark for the x. Part 2. To find the coordinates of the two stationary points on the graph of y equals x to the power of 4 minus 4x cubed. What are they asking here? Let me show you what they're asking. Right, there is, I put the equation in there. There's the graph. The two stationary points is where the curve turns. Okay, so there is 1. There's the one answer, 3 minus 27, and where the other curve turns, see there, would be 0, 0. Okay. Why are they called the stationary points? Because those are the points where the gradient of the graph is horizontal. It's flat, you see? The gradient here on this line, it is positive, and it goes and it goes, and all of a sudden it turns flat there. Horizontal for a moment. At that very point it turns. Then the gradient goes negative, and it goes up, 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 and then it goes flat there for a moment. Yeah, at that very middle point there. Okay, and then it starts going up again. Alright, so how do we find these 2 points? Well, we do that by differentiation, because differentiation gives us the equation of the gradient, the line, the tangent you draw there. Okay, so remember how you differentiate. You say dy over dx. Okay, and you multiply that little 4 with whatever the coefficient up front. So 4 times 1 is 4x, and then you subtract 1 from the 4, gives you 3. Do the same here. 3 is 3 to the power times minus 4, give you minus 12. Subtract 1 there, x squared. Okay, so now And if we put any x value in there, we can find the gradient at that specific point. Now, where the points are stationary, that is where the gradient is 0. And this whole thing indicates the gradient, of course. So we can set this equal to 0. And now we just need to solve this thing to find out what is the coordinates. Okay, so what can we do? We can factorize. Alright, we can factorize out of 4 from there and there. If we do that, what is left? We got a 1 and a 3. And then we can take x squared from there, and also an x squared from there, but there's an x cubed, so 1x will be left. So this will be 1x, and the x squared will be there. Okay, just check. 4 times 1 is 4. Bam. 4 times minus 3 is minus 12. Bam. X squared times x is x cubed. Bam. X squared times whatever that is x squared. Okay, equal to 0. So now we can split this up. Okay, we can say 4x squared equals 0. And we can say, we don't need the 1, so x minus 3 is 0. Okay, we're doing well. So divide the 0, the 4. 0 divided by 4 is 0. Square root 0, x is 0. Here this is x is 3. We now have the two x coordinates. How do we find the y coordinates? Where is a y? There is a y. There, you see? So we want the y, we need to put the x values into these x's there. So first of all, if x is 0, then y will be 0 to the power of 4 minus 4 times 0 cubed. What does that give us? 0 to the power of 4 is 0, 0 cubed is 0, 0 times minus 4 is 0, that means y is 0. So that's the point 0, 0. Then if x equals 3, to find the y, we need to do 3 to the power of 4 minus 4, 3 cubed. This one is a bit tougher. What is 3 to the power of 4? So that's 3 times 3 is 9. 9 times 3 is 27. 27 times 3, what is that? 81. You know how to do 27 times 3, right? You do 20 times 3 is 60. And 7 times 3 is 21. Add it together, you get 81. Okay. By the way, so this is 81. 3 times 3 we did is 9 times 3 is 27. So it's minus 4. 27. 4 times 27. How do you do 4 times 27? Well, that one's not difficult, okay? Because the 4 times table, double it, 27 times 27. 54, double it again, 108. So we got 81 minus 108. What is 81 minus 108? Well, that's 19 plus 8, 27. No, it's not 27. Of course it's not 27. But you can work it out that way. You can say 108 minus 81. It's not 27. It's minus 27 because 100 is bigger. What a question. This is the one that you want you to get an A star in. Okay. You know it's right because I did it with my graph. Remember? Where is it? There it is. Yeah? I showed you the stationary points. There. 3 minus 27, 0, 0. Okay. Might be worth looking at the marks here, right? Differentiating gives you already a lot of marks. So this, even if you got confused, yeah, you get 1 mark for this, 1 mark for that. Just knowing that you have to differentiate. That's good news. Okay, then if you set it equal to 0, you already got half the marks. Okay. Then factorizing gives you a mark. Factorize, this gives you another mark. Look at all the marks at the beginning there. And then I guess from there is 1 mark correct for each one. Okay, so you can pick a lot of marks up at the beginning, even if you don't get the right answer. Last question. So for question B, they want us to do the differentiation backwards. See, they give us the differentiated equation, and we get from there to there, and there to there. So remember what we did in the previous question. Okay? We had to do 4 times 1, which gave us the 4, and then subtract 1. Okay, so with this one, okay, so it was obviously, there's nothing in front of the x. So how do we get the 11? Well, we did 11 times 1, and then subtracted 1, which gave us a 10. So y would be x to the power of 11, because we go from here to there. 11 times 1 is 11, subtract 1, we get the 10. Next one, a little bit more complicated, because there is a 2. To get the 2 to be a 10, we need to multiply it by 5. Alright? So the 2 is still going to be there, but it's going to be x. You just add 1 to that one, it's 5. Because 5 times 2 is 10, subtract the 1, you get 5. Okay, what do they want to know? What is the p? P is whatever hanging above the x over there, which is 11. And the q is whatever hanging above the x over here, which is 5. Differentiation backwards. 11 and 5, we got it. Okay, B1 for each. 1 mark, 1 mark. What a new adventure this new curriculum non-calculated paper is. We're going to have to work on multiplying, decimals, and your mental calculations is quite important. Okay, but don't worry, you're going to practice and you're going to do it. And I'll help you. Bye-bye.